Welcome everyone to this presentation about Power Grid Model DS, which is simplifying data science for distribution system analysis. My name is Peter Salemink. I'm the chair of the Power Grid Model project. I'm a product owner at Alliander, and I also do guest lecturing at the Eindhoven University of Technology. And I'm here today together with Jaap Schouten, who is also product owner at Alliander, and is one of the maintainers of the Power Grid Model DS package. So, to start with, I want to show you some articles from the news from the Netherlands. And I'll translate them for you. So, why is the grid full? What can we do about it? A full grid, what does it mean for you? Waiting list for electricity for 10 years for companies in North Holland. Not enough power. Companies obliged to use less electricity. And the province of Utrecht is even going back to gas because the grid is full. Well, this is the new reality. The energy transition is being held back by the capacity of our grids. And it doesn't only happen in the Netherlands. So these are some articles as well from Germany, Belgium, the UK. It's happening everywhere. These are just some examples. And the energy transition is putting pressure on our grids all around the world. And to show you what it looks like visually, I have I'd like to show you a map of the Netherlands. And as you can see, there's no transport capacity for the largest part of the country, both for consumption as well as for generation. Well, we believe that we should manage our grids in a smarter way. And we believe that smart data science solutions are essential in enabling the energy transition. Why? Well, first of all, grid congestion is real. Renewable integration and electrification are both pushing our grids to the limits. Traditional upgrades are too slow. We've heard that one already multiple times today. But building new cables and substations can take years. And it's not fast enough. So we think that smart solutions can unlock this flexibility. If we have fast and accurate grid calculations, we can enable dynamic congestion management, for instance, better planning, and even have cost savings because of better investment planning. And we also believe that open source accelerates this innovation. So shared tools, for instance, like Power Grid Model, but actually everything that's here at the summit this week, reduce the duplication of code and foster collaboration across DSOs, TSOs, academia, vendors, etc. So that brings us to Power Grid Model. It's a distribution system calculation library. It can do both symmetric and asymmetric calculations, meaning we can do calculations on both balanced as well as unbalanced networks. And it has 3 calculation types. So first of all, power flow, a what-if analysis. So if I have this topology and I have these loads, what powers will flow through the system? What voltages will I have? We can also do state estimations. So if I have a topology and I have some measurements in the system with a certain uncertainty, then state estimation is a statistical method to determine the most probable state of the grid at that moment in time. And short circuit calculation. So if a fault occurs, what currents would flow, for instance? Before we started the Power Grid Model project, it was roughly 4 or 5 years ago, we made a list of requirements of what we think that a grid calculation library should have. First of all, a well-defined software API. It should be easy to use, right? It should be available cross-platform, so Windows, Linux, Mac. So we can use it both locally for personal development, as well as in a cloud environment. And of course, it should have high performance, it should be scalable, and preferably also have native parallelization. So we can do really fast calculations on all types of grids. Well, before we started, these were our requirements, and we did extensive research to see if there was anything that already suited our needs, both open source as well as commercial parties. But, well, we started the project, so we concluded there was not. But these days, we're not doing it alone. So I would like to mention the community in which we work together with the 3 largest Dutch distribution system operators, Alliander, where we both work, Enexis and Stadium, 2 technical universities in the Netherlands, the TU Delft and the Eindhoven University of Technology, and some companies like RSE, VeraGrid, previously known as GridCall, and Panda Power, which have integrated Power Grid model as a calculation engine in their modeling environment. And Soptim, well, I guess you all know Soptim because they're hanging around your neck. It's a company based here in Aken, and they've done major contributions to Power Grid model in the last year. So and together with the community, we've actually done many things in the last year, and I just want to highlight some of them. So first of all, we added support for columnar data. So Power Grid model is originally a row-based data format. But columnar data integrates better with your databases, and it can also potentially decrease your memory usage. Then we have generic branch, which is actually a contribution from Soptim. So, well, the name says it, it's a generic branch. You can model any type of branch with it, from a cable to a transformer, all in the same way. Asymmetric lines, which was a contribution by the Eindhoven University of Technology. So previously, Power Grid model only had symmetric lines, but well, now we also support asymmetric lines. Current sensors. So for state estimation, we already had voltage measurements and power measurements, but since a couple of months, we now also support current measurements to make your state estimation even better. We also support full observability for radial grid, or at least to check for full observability. Because, well, before you can do a state estimation calculation, you need to know, is my grid observable in the first place? We're also working on an observability check for meshed grids. So that's something you should expect sometime soon. Not making promises on when. And then, of course, the reason why you're all here, the latest package in the Power Grid Model suite, and that's Power Grid Model DS, a data science toolkit for Power Grid Model. And I'd like to give the floor to Jaap to tell you more about it.
Well, thank you, Peter. And these are, I think, all really exciting new developments and a really strong package, the Power Grid model. And I think I'm speaking on behalf of all the data scientists at Alliander that we are really excited to be able to use this already for a couple of years within our organization. Because what you said, we believe that building smart solutions is essential to solve this energy transition crisis we are having. And that's why we're building all kinds of solutions within Alliander. So there's a lot of teams working on using the Power Grid model in production settings to solve all kinds of problems. And that's where the Power Grid Model DS package project started. So what it entails is that we built a Python wrapper, which is really lightweight and easy to use around the Power Grid model calculation engine, which does a really fast load flow to be able to solve real-world problems with it. And that means combining the calculation core with 2 very well-known tools, I think, within the Python community. Certainly NumPy. I think everybody using Python has worked in some form with NumPy, and it's really useful to do numerical analysis on larger systems. And we combine that also with a graph engine, WizWorkX, to, in the setting of course, a Power Grid model being a graph, is really useful and needed to build software solutions in the data science setting. So to illustrate where this project, the data science toolkit, comes in, I want to illustrate a very generalized workflow for building a data science project. And on the top, you can see, of course, that analyzing a power grid involves doing a lot of power grid power flow analysis, where the power grid model calculation core comes in. And what we are adding with the Power Grid Model DS project is supporting the steps in between. So whenever you start a project, you get raw data. You need to start modeling, analyzing that. Of course, you need to clean it because there's always something wrong with the data. And after that, we get a start point for our simulation. For example, we're simulating new customers, future grid investments. And we're starting to do modifications to the grid and seeing what impact that has. And that's something you can do really easily with the Power Grid Model DS project. Then we do, again, power flow analysis, and we want to analyze, has that made the impact we want? And that's something that a lot of teams were doing within Alliander, and we have centralized the tools to do that, and have now released that as a separate package within the Power Grid Model suite, because we think it's going to help you guys as well a lot in using these analysis tools. So, like Alex said in the morning today, we want to also see some code and see some real work. So I will show some things about how this works and how this looks. So what are we modeling? We're modeling components in a grid, like nodes, which represent bus bars, for example, in the network. They're connected with lines, with transformers. And these things we can model. And we can model them in different ways. So depending on what you're doing, we can model them like on the one side as an array representation, in which you can model large amounts of data and analyze them in a batch, generate input for a load flow engine. And on the other side, we can represent them as a graph, which is really useful in analyzing structure, analyzing local, how the network is configured locally. And this is what the Power Grid Model DS package adds and does for you. So we built a graph model based on RussWorkX, which we found at the moment to be the fastest solution in Python to use in this setting. And on the other hand, we use NumPy arrays to facilitate the batch analysis. And on the graph, you can think of asking things about the network in the preparation step. Are there any cycles in this network which I maybe want to filter out or want to do something with? What is the path from one point to the in the network to another? How is the network configured? Which things are connected to each other? And these are all things where, in each of the projects we're doing, they are essential to build a complete package, a complete solution from A to B. And then the other representation we use is using arrays. And arrays can be really useful to, for example, filter on large scale in a network. If you want to find all the contingencies in a network, you want to filter over the whole network, or want to filter out on different types of assets in the network. So that's something the Power Grid Model DS package adds, and you can extend it for your use cases to answer questions which are useful to you. And these two things need to be synchronized. You need to be able to interact with that in an easy way, in a Pythonic way. So we manage this structure in a grid class, which contains both of these representations and allows you to build a stable and robust solution which can be built fast on one side, because you don't have to think about how this works when you're starting a new project, so you can prototype easily. But also, on the other hand, is very robust and can run in a production environment. I think these are really nice features we are building to build great software. But there's one more feature I want to highlight, and it has nothing to do with building great software, but for some reason it keeps popping up as the most requested feature I think for the past 5 years. And I agree, because if you're building something, of course it breaks and it goes wrong and people put in wrong inputs, and then you need to analyze what's happening. So the Power Grid Model project also includes visualization aimed at developers who are trying to solve these problems. And you can only do that if you can see and visualize how the network looks. So I think this is a really strong feature we are having. And then having all these features, I think it's nice also to highlight some of the things we're doing with it. So within Alliander, as a DSO, we're building different kinds of data science solutions. And they all need to do an enormous amount of load flow analysis. So starting at looking towards tomorrow, in the system operation field, we're using this to analyze impact on a network for 24, 48 hours ahead, forecast contingencies, and be able to prevent those and steer customers in the right direction to solve that. So that's on the really short time scale. Looking further ahead, you can use it to plan, for example, for maintenance or solve outages. How do you handle that? You need to do a lot of simulations. What if we switch the network one way or another? So that's something you can build with a simulation tool like Power Grid Model. Then looking at the problem we started with, there's a lot of new customers wanting to be connected to the grid. So we simulate these customers in the grid and see if we can give them any way of being able to connect to the grid, which contracts they need, or we need to be able to facilitate their being connected, if we can do anything to change the network on a short time scale to be able to facilitate new grid connections. And then looking on solving the energy crisis for the long term is that we built a lot of simulation tools which simulate the grid for 40 years ahead and are doing that to plan investments and see if investments are effective. And on the other hand, also trying to simulate strategic decisions. What if we invest more in maintenance versus investing more in new network connections. And all these things, they use the same basis, being the data science toolkit. So you can, if you're in one of these businesses on any of these timescales, I think the Power Grid Model DS project can really help to build fast, so build something which you don't need to start from scratch, but also build something that's really robust and will end up being good and maintainable software. And we're really excited that we are able to share this in a community like this, in the open source sphere, to learn from you guys, to help, but also to, of course, to see if you can then also contribute to these projects, and very happy to be here to share these developments. So I think with that, we want to give the floor to some questions. Of course, we want to ask you to follow us, like and subscribe, you always say, but go to the GitHub page. You can subscribe to our email list. You can start a project. And we also have a yearly meetup which you can attend to learn and keep in touch about the Power Grid model. So for that, I want to thank you for the listening and hope you have some questions for us.
Yeah. Let's test.
Okay, just a quick question. For the Power Grid model, does it support the active distribution power network? So is it support ADN, the simulation of ADN? Active distribution power network.
Like active and reactive power, you mean?
Yeah.
Yeah. So it does. We do both. Maybe Peter is the expert on the load flow side. So don't know if you want to add, but yes, both are supported.
Yeah. So we do calculations on both active and reactive power. I'm not really familiar with the term ADN though, so maybe we need to have a little chat afterwards. But thanks for asking a question. Yeah.
Thank you. On the state estimator, could you comment on if there are any plans to include for the future measurements from these so-called micro PMU phaser units? These very, detailed.
Yeah, I'm going to give that to Peter as well. Sorry, I'm more in the simulation part, so the physics questions I'm going to give to Peter.
Yes, well, we actually support phasor measurements as well. So both for voltage, but also for the current measurements now. So that's one of the latest additions to in the current sensors.
Thank you very much for the presentation. Just had one question. So I know you work at Alliander, but with the other DSOs which have been using Power Grid or with whom you've been in contact with, which have been the analysis most requested or most popular among them that the data science toolkit enables?
Yes, like I said, so one of the things that's really much requested is the visualization part. And I think that speaks in a broader sense to developer experience, so being able to develop in a easy and well-supported way. So I think that's something it really brings to that. And in addition, I also think the interaction with loading in data and analyzing and filtering out things you don't want or things you want to change is a big part of what's used.
Thanks. Just a small question. Is it possible to model active generators in state estimation?
Well, in state estimation, the answer is yes, because we don't model anything. So you have your measurements. So as long as you have your measurements in the grid, you can model everything. For power flow, it's not included. So the component is not there. But it should not cause an issue for state estimation. Any other questions? If not, then thank you all for joining.
Yes, thanks a lot.